All right, let's crush an Mtel question. This one says an absolute value function of the form y equals absolute value of x plus b plus c passes through the points negative 16, 13, and 16, 15. What is the location of the vertex for this function? All right, so it's important to know some stuff about absolute values to answer this question. So this is our standard form of an absolute value function, where a is our stretch value and hk is going to be our vertex. So when they're telling us in the question that y equals the absolute value of x plus b plus c, they're telling us that the a value is 1, which is telling us that the slope of our absolute value is 1. So the most basic absolute value function is just going to be y equals the absolute value of x, which is going to have a v shape and look exactly like this. So absolute values are always a v, because if you think about what's happening with y equals the absolute value of x, we basically have the graph of the line y equals x on the right side, but then y never goes negative, because what an absolute value does is flips the sign of the x, right? So if we go negative x, all of our y values are going to be positive because we took the absolute value of a negative number and got a positive number, right? And we end up with this v shape all the time. So all absolute values are going to give us this v. Well, this v is symmetrical, which is pretty important to this question because they're giving us 2 points. And if we think about the symmetry of this v, we can kind of figure out what's going on with the vertex. So let's graph these 2 points and think about what's happening in between them. So I'm going to throw a point there. That's our 16, 15, and then we've got a negative 6, 13 point. It would be somewhere over here, something like that. And you can think about these 2 points being connected in a V shape. It's going to look something like this, and it's symmetrical on both sides. We've got 1 point, negative 6, 13, and the other point, 16, 15. Well, if we had 2 points that have the same y value, we'd be able to do some tricks with the symmetry here. So if I walk my way down this line from 16, 15, I could get to a point with a y value of 13. I'll be able to do a little trick with that. So I know the slope of this line is 1 because our a value is 1 in our equation. So if I go over 1, I should go down 1. If I go over 1, I should go down 1. I want to get down to 13, so I have the same y value at this point. So I could think about a point at 14, 13. And now I've got 2 points with the same y value. Both of these points have 13 as the y value. And the vertex should be directly between those points because there's a symmetrical V shape happening. So if I take the average of negative 6 and 14, that should give me the x value of my vertex. So to find the average, we add our 2 x values and divide by the number of points. So negative 6 plus 14. And then divide that by 2. That gives us the average. So negative 6 plus 14 is 8. Divided by 2 is 4. So I know the x value of my vertex should be 4. So already the only answer that has 4 as an answer is answer B. But we can also figure out the y value. Because the slope of this line is 1, every time we go over 1, we should go down 1. So I have to go over from 14, 13. I have to go to the left 10 to get to 4. Which means I also have to go down 10. So I could do 13 minus 10, which would give me a y value of 3. So the point of our vertex should be 4, 3.